Hey kiddos, hope you're having a great day. We are getting ready to start our next unit in Algebra 2. So our unit is radicals. So we're going to be dealing a lot with square roots and cubed roots and things like that. It's a pretty interesting unit, I think. This stuff shows up a lot on like the ACT and it'll show up a lot in your future classes. So it's a really beneficial unit. But this is a rather long unit. We have a lot of learning targets. I want to say like 8 or 9. So make sure you are keeping up with your notes and taking good notes, and you keep them all in a binder or a folder, something organized. That way when test day comes, you have everything in one spot and you're ready to study. So um, let's get right to it. So what we're going to be doing today is we're going to be simplifying radicals. I think that's spelled right. I don't know. Simplifying radicals. And this is going to be part 1. So this is the first half. Our learning target is I will learn how to simplify radicals. So there are multiple ways to simplify radicals. There's 2 ways to do it, which is typical square roots. And then you can also do like cube roots and fourth roots, and then you can also do it algebraically. So this first part is just going to be the basics, and then in a few days we'll do the more advanced algebraic stuff. So the first thing you need to know when you're simplifying radicals is you have got to get a grasp on your perfect squares. So for your perfect squares, you need to be able to like quickly recall these off the top of your head. So I'm just going to write them down in our notes because that's super beneficial. So we're going to have 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, 6 squared, 7 squared, 8 squared, 9 squared, 10 squared, 11 squared, and 12 squared. So these are probably the most used. You might even go up to 15 are the most common ones, but definitely 1 through 12. So you need to be able to recognize perfect squares. So like 1 squared, I think we can all agree is 1. 2 squared is 4. 3 squared is 9. 4 squared is 16. 5 squared is 25. 6 squared is 36. 7 squared is 49. 64. 81. 100, 121, and 144. So these are the most common ones. Excuse me. Again, you might even say go up to 15 and say those are the most common ones, but you definitely should have quick recall abilities through 1 through 12. So being able to recognize that, 25 is a perfect square. So let me backtrack here. A perfect square means that something times itself is going to give you a number. So like if I was to take the square root of 25, so that means what times itself is 25, and that's going to be 5. So it's a perfect square if it's like an even whole number. So like if you try to take the square root of 2, that's not going to work out because nothing times itself is 2. But I think you all are familiar with square roots. You've seen them before. But we're just kind of building on that prior knowledge for this unit. So knowing these and being able to quickly recognize, it's a perfect square, that'll save you a ton of work in this unit. So make sure you kind of get these in your memory, get used to them, practice them, so on and so forth. So what we're learning how to do in this unit is we're learning how to simplify stuff that isn't a perfect square. So for instance, let's get started with the what did I do with that paper? Here it is. Let's just start with just some basic vocab and terms to know. So another word for square root is radical. So if I say radical, I essentially mean a square root. Radical is used a lot of times for like cubed roots, fourth roots, stuff like that. It's just a broad term that encompasses all of those things. So for radicals, their generic form is you're going to have a square root with a in the middle a little n out here, and that's going to equal b. So this is a generic form of a radical. The little n, that is called an index. The a is called your radicand, or radicand, however you want to pronounce it. And then b is what it equals. So essentially in this form, it can also be transitioned into b to the nth power is going to equal a. And there are some properties of radicals. So the properties are the nth root of zero. The nth root of 0 is always 0. If n is odd, then you have one real root. If n is even, and a is positive, then two real roots. Oop, I ran out of room there. Two real roots, but them being positive and negative. So for instance, a lot of times when we think of like the square root of 25, a lot of you could tell me, oh, that's going to be 5. But really, if we want to be mathematically correct, the square root of 25 is 5 and negative 5, because 5 squared is going to give me 25, and negative 5 squared is also going to give me 25. For a square root, this is what we're used to, the little n that's out there is always a 2. So if you don't see a number there, you always assume it is a 2 to be a square root. And then lastly, if n is even, a is negative, then no real roots. So what we mean by real roots is dealing with real numbers. So like negative infinity to positive infinity. Real numbers are, you're really going to be dealing with the positive numbers essentially. But in this unit, we're also going to learn about imaginary numbers. So that's what it means when it says there's no real roots. If you don't have real roots, you have imaginary roots. But we haven't quite got there yet, but this is just a good intro to what is to come. We will be learning what imaginary numbers in this unit. Yes, imaginary numbers do exist. They come from when you take the square root of a negative number. And that's because you can't square anything that's negative and get a negative. It's because like negative 5 squared is always going to give you a positive. It's very trippy, very cool. So those are some basic rules for radicals. So what we're going to be learning how to do today is simplify things that are not perfect squares. So I know that if I gave you, oh, what's the square root of 49? You'd be like, oh, 7. But what if I said, what's the square root of 200? We don't know. 200 is not a perfect square. That's what we're going to learn how to do today. So there are 2 ways to do it. So method 1. Method 1, I call it the perfect square method. All right, for the perfect square method, you'll be given something like this. You'll be asked to find the square root of 216. So we already know it, or we're using our calculator and we're like, oh, it's not a perfect square. Because if I put the square root of 216 in my calculator, it's going to give me some big wonky decimal. So for the perfect square method, what you're trying to do is you want to find the biggest perfect square, which I'm going to abbreviate PS, that goes into 216, or goes into whatever number is in the middle here. So you have to find the biggest perfect square. So in your calculator, it's really going to be, that is so blurry. There we go. In your calculator, it's really going to be a lot of guess and check. So 216, is it divisible by 49? Nope. 216, is it divisible by 64? Nope. So we'll try one more big one, divided by 81. Nope. So we'll go down. We tried 49, so let's try 36. Yes, 36 works. 36 times 6 is going to give me that 216. So since 36 works, I'm able to break down the square root of, you all can't see that. I'm able to break down the square root of 216 to make it the square root of 36 times the square root of 6. And then the square root of 36, that's going to be 6. And the square root of 6, we can't simplify that down anymore. So the simplest form of radical 216 is 6 radical 6. So the way you know that you did this right is you're going to want this to be not really a prime number, but a number that you can't simplify down anymore. So like if you got, essentially like you can't break this down anymore because it's only 2 and 3. And for square roots, you're looking for pairs, which will make more sense here in a minute. This is not my preferred way of doing it, but I do want to show you how to do it. I think it is beneficial and sometimes it's faster. So essentially you're just looking for the biggest perfect square. It has to be the biggest one or this will not work. The biggest one. So it's going to take some trial and error, and that's going to give you one that you can simplify and one that stays the same. So if I want to do the same thing here, I want to find the square root of, you're going to find the biggest square, and then you're simply simplifying. If I want to find the square root of 300, I'm going to think to myself, what is the biggest perfect square that goes into 300? I do my guessing and checking, and I realize that, 100 is going to go into that. And 100 times 3 is going to give me the square root of 300. Or 100 times 3 is going to give me 300. So the square root of 100 is 10, and then my radical 3 stays. So that's example 1, that's example 2, example 3. And then lastly, if I want to find the square root of 128, I do some guessing and checking in my calculator. So we'll do 128 divided by 81. Nope. 128 divided by 100. No, that's not going to work. It has to be evenly divisible, so you can't be getting these big decimals. How about divided by 49? Nope, that's not going to work. Looks like I skipped 64. 2. Yeah, so this one works. And I'm going to get I'm going to get 64 times 2. Square root of 64 is 8. And then 2. So I think this method takes a lot more guessing and checking work than the next method I'm going to show you, but it is an option. And I did want to teach you how to do it. Some people like this one better. I prefer the other method, but both are good and both accomplish the same thing. Okay, so method number 2. I call it the factor tree method. So let's say we want to find, we'll do the same example. So using the factor tree method, if we want to find the square root of 216, we're going to have to make a factor tree for 216. So we just need to find 2 factors of 216. Doesn't matter what they are as long as they are factors. So we'll do 216 divided by 4 is going to give me 54. 4 and 54. And then we're going to keep going until we cannot simplify these anymore. So we're looking for prime numbers. This is called prime factorization, if you haven't heard that term before. So 4, I can break that down into 2 and 2. And 2 is a prime number, so we stop there. 54, I can break down to 9 and 6. I can break 9 down into 3 and 3, and 6 down into 3 and 2. 2 and 3 are both prime numbers, so this is where we stop. So the first thing you're going to do is you make a factor tree, which I'm going to abbreviate FT. The second thing you're going to do is look for groups of the size of your n. So remember, your n is your index, And if we don't have a little number out here, we assume it's a 2. So we're looking for groups of 2 of the same number. So I'm essentially looking for pairs. So here I have a pair of 2s, and I have a pair of 3s, and then I have a 3 and a 2 that are left over. So once you find your pairs, pairs go on the outside of the radical. So pairs go on the outside, and you're going to use multiplication to do so. So we're going to have 2 times 3, and then we're going to have a radical. And then the last step is what's not in the radical. What's not in a pair goes in the radical. And we're again using multiplication. So we're left with a 3 times 2. So 3 times 2 is going to give us 6. 3 times 2 is also going to give us 6. And I'm going to get 6 radical 2, and which is also what I got up here. So yay, it works out. All right, let's do another example. Let's do a different one. We'll do we will do example 2. That's going to be, we'll do 6 radical 12. So sometimes you're going to have coefficients out here in front of your radical. You're not going to worry about those until the very, very end. So we're going to first start with 12. Factors of 12, that's going to give me 4 and 3. And then we're going to have 2 and 2. So again, I made my factor tree. Now I'm looking for pairs. What's in a pair goes on the outside of the radical. What's left over goes on the inside. So the radical 12 is the same as 2 radical 3. But I have to deal with the 6 over here. The 6 is also on the outside. So we're going to have to multiply that by the 2 that's on the outside. So 6 times radical 12 is going to give me 6 times 2 radical 3, which is going to give me 12 radical 3. And we'll do one more example. We will do the square root of 225. Again, I'm going to make my factor tree. Doesn't matter what factors I use. I'll use 5 and 45. 5 is a prime number. So I know I've mentioned this before, but I don't think I said it in this video. A prime number is something that is only divisible by itself in 1. So 5 divided by 5 is going to give me 1, and 5 divided by 1 is going to give me 1. No, I'm sorry, it's going to give me 5. Divided by anything else is going to give us a wonky decimal. So that's what a prime number means. And then 45 is going to be 9 and 5, and then it's going to be 3 and 3. So when I do this one, I'm going to get 3s, and then I'm going to get 5s. So I have 2 pairs. 5 times 3 equals 15. Whoops, see, this one is a perfect square. This one goes up to 15 because 15 squared is going to give me 225. So had I recognized that, I wouldn't have had to do all this work. But even if you don't recognize that, if you still do this process, you can still end up with the perfect square because of my pairs, they both go on the outside. There's nothing to put in the radical. Okay, so that was the long of the short of it. This is like essential skills in order to be able to do the rest of this unit. So that's why this video is a little bit lengthy, a lot of examples. So in Delta Math, there is a section about doing perfect square recall. So working on beating a timer. There's a section where you have to do method 1. That's the second section. And then the third section, you have to do method 2. Well, you can do either, but I'm going to ask that you do this method. That way you get practice with both. When we get to like the quiz and the test, I won't care which method you use, but for practice, I want you to do method 1 for the second section, and it says guided on it, and then the other one just says simplifying radicals. I want you to do the factor tree method. So whichever group of you are at home today, when you're watching this video, bring your questions to class tomorrow. Make sure this video gets watched and you bring your notes to class with you. But I hope you all have a lovely day, and I'll see you when I see you.